So we're going to look at the product rule for derivatives. Unlike the rule for addition and subtraction, which allows us to break them apart in separate terms, finding the derivative of each, and then adding them back together or subtracting them. In this case, the products and quotients, which are fractions, quotients are rational functions, they have a unique set of rules. So in general, we would take, and this just states the derivative of d with respect to x of the functions f of x multiplied by g of x is then broken apart as finding the derivative of the first function multiplied by just the second function. So I'll show you here. So this is finding the derivative of that first function multiplied by just the standard second function. Then we would add that, and I forgot my x there, but it's adding that to the next function, to the first function, f of x, and then multiplying that by the derivative of g of x. So this is a lot easier to explain as we work through math. And so we'll take a basic problem that we could solve with derivatives in general, but we're going to use the product rule to make sure that it turns out. So to prove that it doesn't work, as in addition and subtraction, what I want to do is I just want to show what x squared times x3 would look like if we were to do it two different ways. So the first way is we're going to take x squared times x to the third. This is not using the product rule. This is just proving how this should look. So we have x squared times x3. Well, we would just add these exponents. So we would have x to the fifth. So if we were to find the derivative of that, we know that x to the fifth is in fact equal to x squared times x3. So in taking the derivative with respect to x for x to the fifth, we would find that that is 5x to the fourth. So we know this to be true. And if that is true, and we try to use the same rules of addition and subtraction, where we break these two variables apart that are being multiplied, and we try to use that rule to find separate derivatives, we end up with something quite different. So if we have the derivative of d of x, let's see here, x squared, and we multiply that by the derivative, d with respect to x of x to the third, you might already see it, but we're gonna end up with something quite different. So we're going to end up with 2x to the first multiplied by 3x to the second, and that gives us 6x to the third, which is not the correct derivative, as you can see. So it is very important that we use that rule. So let's go ahead and let's rework this using this product rule for derivatives, and we will do that by taking, it says here that we take f prime of x for the first one here. So for x squared, we're going to call that our f of x function. I'll just list this out. And then the other one we'll call our g of x. So we find the derivative of our first function multiplied by just g of x, meaning that we multiply that by x to the third, plus we're going to take the derivative, and I'm doing this a little bit out of order, which is okay, multiplication, that's okay to do that. So we're going to take the derivative of d with respect to x for the next function, which is x to the third, multiplied by the first function, not the derivative of, but just the first function, x squared. Now, obviously for this one, this is a little too drawn out for something like the product rule. We could have, like we did in the beginning, just simply combine those. As you see, they get much more complex. In fact, sometimes we're not actually given a function. We're given that f of 2 equals a value and f prime of 2 equals a value for the derivative. So do try and do work through your product rule. It will be very important as we get into much more difficult functions. So in this case, let's just work left to right here. We're going to have the derivative d with respect to x of x squared. So that's going to be 2x. So that's taken care of. And then we just bring down multiplied by x to the third. And then we're going to add that. And next we have the derivative here of x to the third. So we're bringing that down. So we have 3x to the second power. And we bring down our x squared, so multiplied by x squared. So now we can start combining these. So we have 2x times x3, so that's going to give us 2x to the fourth, plus we have 3x squared times x squared, so we're going to have plus 3x to the fourth. And since this is addition, we need to make sure our variables have the same exponent powers, and they do. Since they have those same exponent powers to the fourth, we can combine this further. 3 plus 2 is 5, and that variable to the power is just x to the fourth. So 5x to the fourth is what we came up with for our internal portion here. We had x squared times x3 is x to the fifth. The derivative of that is 5x to the fourth. So it definitely works, and it works every time. So let's take a look at a little bit more difficult one. Come down here and we'll work through this. So we have for the function y is equal to two separate products, two separate terms, and they are the product of each other. So you might see that we could probably FOIL this out. And once we FOIL this out, then we would have a nice long polynomial. And in that case, we would be able to use the addition and subtraction rule that we could solve each individual term as a derivative and then combine them. But again, as we get into more complex functions, you're going to find that working well within the guidelines of the product rule for derivatives is going to be essential. So let's find out what y prime is for this function. So to set this up, remember that we're going to call this, and in the beginning, it's okay if you just want to call each one of these by a function name, so you remember how to lay those out. So we'll say that this is f of x and g of x. Let's go ahead and rewrite that formula. So we know that we need such that y prime is equal to the derivative of the first function, and that first one is x squared minus 1 multiplied by the second function as a whole, so that is 3x to the fourth plus 2x, and then we will add the derivative of the second function. So we just rewrite 3x to the fourth plus 2x multiplied by the first function, which is x second minus 1. Okay, let's bring this down to the middle here and work on this a little bit easier. So start slowly here with working left to right, taking this this derivative of x squared minus 1. So in doing that, we would bring our x exponent of 2 out front. So we have 2 times x to the second minus 1. So it's, and what I mean by that is it would be x to the second minus 1 is going to give us simply x. We also, and the reason that I did that so quickly, rather than using the rule to also split this apart using addition and subtraction rules for derivatives, is that we know that any derivative to a constant, which this would be, is going to be 0. So the derivative of x squared minus 1 is simply 2x. And that is going to be multiplied by, so we are going to multiply 2x by the second function, which we know is 3x to the fourth plus 2x. Plus, and then we have the derivative of this one. So in this case, if you still want to split them apart, hey, that's fine. So we could say that this is the derivative, and I'm going to start writing it a little bit differently here. I'm just going to, let's see here. Actually, no, I'll just stay consistent. We'll just say the derivative of 3x to the fourth plus the derivative of 2x. And we want to make sure we put brackets here because we split those apart, but that has to be done first. That definitely is, that is considered a term, 3x to the fourth plus 2x. So we want to do that before we end up multiplying by our x squared minus 1. So let's continue to bring this down. So we have 2x, 3x to the fourth plus 2x plus the derivative of this first one, 3x to the fourth. Well, that's 4 times 3. That's going to be 12. I'll put a parenthesis here just to get in the habit of it. And that's going to be 12x and 4 the fourth power minus 1. That's just 3. Plus the next derivative, which is 2 times 1, because x to the first power. And then x is then reduced, so that is gone. So we're going to have 12x3 plus 2 multiplied by x squared minus 1. All right. We can now distribute, and we'll start again left to right here. So I'm going to distribute this 2x times 3x to the fourth. Well, 3 times 2 gives me 6. And an x times x to the fourth. We're just going to add those powers together. So we have 6x to the fifth plus, and then 2x times 2x. And 2x times 2x is going to give us 4x squared. Plus, and then we're just going to FOIL this out. So you can rewrite this if it's more comfortable, but I'm just going to work from right to left in my factoring. So I have -1 times 12x to the third is going to give me a negative 12x to the third, and -1 times 2 is going to give me -2, and then x squared multiplied by 12x to the third. Well, that's going to give me a positive 12x, and that's going to be to the fifth, and then plus x squared times 2 will leave me with 2x squared. So we can combine like terms within this as well. We can see that there is a way to rewrite this actually from highest power to lowest power. And let's go ahead and rewrite this. So we're going to end up with 6x to the fifth plus 4x squared minus 12x. Let's see here. We'll go plus 12x to the fifth. I'm going to rewrite this highest power to lowest. Minus my 12x to the third. And then we'll have plus 2x to the second power. And we'll have minus 2. And then at this point is when we want to start looking at, and I do apologize, I wrote fifth. It's negative 12x to the third. And then we'll combine like terms. So let's see, we have 6x to the fifth and 12x to the fifth. So we have 18x to the fifth. Next, we can combine positive 4x to the second and 2x to the second, which is 6x to the second, or squared. And then we have minus 12x to the third minus 2. All right, so we got through it. And like I say, it's going to take a little time to get comfortable, but it is well worth doing these over and over so that you can see the pattern, so that you can see how to work through that correctly with your algebra. Again, be careful with the exponents. Be careful with, especially with your positive and negative. Make sure you have parentheses around terms, and you should be fine. Hey, thanks for watching. Hope that helped.